Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, viewers. Welcome back to our math class. In this tutorial, we'll be discussing about fractional calculus. Good. What is fractional calculus? Fractional calculus is a generalization of ordinary differentiation and integration to arbitrary non-integer. We have a differentiation of a particular order, which is of order k, a derivative of order k, which I have the first derivative with respect to x. I have ordinary differentiation, whereby my integer here is 1, because the integer over here is what? 1. Then the second one, I have the half derivative. The half derivative, whereby my integer is my non-integer k, which is 1 over 2. This is a fractional differentiation. Whereby when you are asked to find the half order derivative of a particular function, how are you going to do this? Whereby we are going to apply what is called fractional differentiation under fractional calculus. Good. Before you can move to the applications of this fractional calculus, we just have to discuss about the origin of this fractional calculus. This fractional calculus was a bright idea of Gottfried Leibniz, originating in the end of the 17th century, around 1695. And this fractional calculus can be applied, or it is applied to many fields, such as we have flapping, we have wave propagation, we also have biological material. It is also applicable in control and robotic, and also in quantum mechanics. These are some aspects in which the fractional calculus is being applicable. Now also, if my y is equal to what? S raised to the power of n, then the first derivative of this function is going to be what? N, you multiply it by the power, then you minus 1 from the what? From the power. Then the second order derivative is equal to what? N, you multiply by the power again, n minus 1, then you minus 1 from the power is going to be what? N minus 1 minus 1, which is what? N minus 2. For the third derivative also, I'm going to have n minus 1, n minus 2, then I have x raised to the power of n minus 3, because I'm dealing with the third order. Good. What about if I'm not dealing with this order of what? Order k. So this is same thing as I have d, it continues like this until I get what? Order of k over what? This power of k. This is equal to what? n minus 1, n minus 2, and it's continuing to this stage until I'm going to have n minus k plus 1. Then raised to the power of what? I'm going to have x. Now raised to the power of n minus k. Let me call this one equation 1. So from this, my equation 1, from this equation 1 that we have, is going to lead to what? Gamma function. This is my equation 1. So from gamma function, n into the bracket of n minus 1, n minus 2, I'm going to have n minus k plus 1. Let's power of x n minus k. This is equal to what? The gamma of n plus 1 over the gamma of n minus k plus 1, then x n minus k. That is, from here to this part is equal to what? Gamma of n. This is equal to what? Gamma of n plus 1 all over the gamma of n minus k plus 1. Then I have my x, this remaining part x, raised to the power of n minus k, which is same thing as d of what? Of order k. That is what? The derivative of order k is equal to what? This. So in case if you are now asked to find the derivative of half derivative now of a particular function, half derivative of a particular function, what will they have? This is what we want to discuss in this class of what? Of fractional calculus. Don't forget to subscribe on my YouTube class for more exact video at Rock Maths class for more exact video on fractional calculus. Assalamu alaikum.